Hi, this video we're going to look at the periods and the frequency. Well, for any periodical events, which, for example, if you have something like this, a sine wave, or when you have like a square wave, it's periodical. So let's take a look. This is going to be one cycle, right? So how long the time it takes from this event to repeat itself, that's going to be our period. That's going to be our t. For the square wave, it's going to be from here to here. That's our t. So periods, it's the time take for the event to repeat itself. So it's going to be a unit of seconds. And how about frequency? Frequency, I'm going to have a unit, I have a symbol as F. Periods actually have the symbol with T. So frequency and periods are related. It's reciprocal. So knowing that frequency going to have a unit of per second. Per second, also known as Hertz, Hz. For example, if for this event to repeat itself is 0.02 seconds. So the period, which means 0.02. Then what does frequency tell us? It's reciprocal of t. That means 1 over 0.02 seconds. And if you calculate, we're going to get 50 per second. So what does that mean? What does that mean? It means number of cycles per second of time, which means how many frequency every second. Every second, we're going to see 50 of these periodical events. That's our frequency. Well, for example, when you listen to the radio, maybe now not too much, let's say 93 hertz. What does that mean? Which means that radio wave is transmitted 93 cycles every second. Okay. So that's a period and a frequency. And now let's look at some simple spring mass system. So if you have a mass here, it's tethered to the spring and it's on the ground. And for this spring mass system, it's basically going to be a vibration system. So if you push it down on the mass and then let it go, what happens? It's going to oscillate, right? It's going to go up and down motion. And so there's a frequency, there's a period. So here they have developed the equation for that. It's going to be 1 over 2 pi over k. It's a spring constant. M is a mass. And the spring constant is going to have a unit of Newton per meter. Okay. And of course, we know T is going to be reciprocal of frequency, right? Okay. Now, another example. Why don't we put some numbers in here then, actually? So imagine this mass is 2 kilograms and this spring constant is 5 Newton per millimeter. Then what's going to be the frequency for this spring mass system? It's going to be 1 over 2 pi, and K is 5 Newton over 5 millimeter divided by mass, which is 2 kilograms. Well, we're going to watch out for the unit because this is going to be changed to meter. We're going to have our desirable unit meter here. We want to get rid of millimeter. 1 meter is 1,000 millimeter, right? So you will have Newton meter. Now let's look at the dimension here. Inside of the square root, if you have a Newton per meter, then you have kilogram. What do we have, right? Let's see. Let's use dimension homogeneity to figure it out. Newton is kilogram meter per second square. Then divide by meter. Then that meter canceled out. You also realize kilogram canceled out. Then what's inside this square root is 1 over second square, then that's take a square root, it's 1 over second. And that's what we desired. That's our frequency unit. How many cycles per second? So if we do that, we're gonna get correct unit. And if you put your value in, so 1 over 2 pi, then, oh, I made a mistake here. There's no 5. It's 5 Newton per millimeter. So we will have 5,000 divided by 2. All of that gonna give us 8, around 8 hertz, or 8 per second. Okay, so that's for a spring mass system. Another periodic events you will encounter is this pendulum. You know, if you have a pendulum, it's gonna swing back and forth, right? If you go this way and come back to original position, that's one event. And for that pendulum, they have also developed the equation for period, and that's going to be equal to 2 pi L over G. And what is our L? L is the length of this pendulum, and G is our acceleration coefficient, 9.8 meter per second square. So that's all I have for this period and frequency concept. All right, I'll see you next time. Bye.